When dividing two rational expressions, we can invert the second fraction and change it into a multiplication problem. Before we multiply straight across the top and straight across the bottom, let's see if k minus 5 or 2 minus k are factors of k squared plus 3k minus 10. We're looking for two numbers that multiply to make negative 10 that have a sum of positive 3. We see that the sum is positive, so the larger of the two factors of negative 10 must be positive. So 5 times negative 2 is negative 10. 5 plus negative 2 equals 3. So now we can rewrite k squared plus 3k minus 10 as k plus 5 times k minus 2. This 2 minus k looks suspiciously similar to k minus 2. So let's take a closer look, see if it is exactly the same, or maybe we can modify it a bit to help us cancel the k minus 2. I'm going to change the order of these two terms here. So I'll start with the negative k and add 2. And we notice that k minus 2 is the opposite of negative k plus 2. Let's go ahead and factor out a negative 1 from both of these terms. That negative 1 comes out front, leaving us with a positive k and a negative 2. So this expression here is equivalent to negative k plus 2. And this looks like it's going to help us because here's our k minus 2 that also appears in the numerator. So I'm going to rewrite 2 minus k as negative 1 times k minus 2. Before we multiply straight across the top and bottom, let's go ahead and cancel our common factors. We have k minus 2 divided by k minus 2 equals 1. K plus 5 divided by k minus 5 does not equal 1. And distributing that negative 1 to the k minus 5 wouldn't help either. They would still have opposite signs. So let's go ahead and multiply straight across the top and straight across the bottom. On a multiple choice test, you might see a different version of this that's equivalent to this expression. This, instead of distributing the negative 1, we could actually put that out front. So here's another way of writing our answer. A technical note, we should make a note of any excluded values from the original problem that are not apparent in our answer. Now, we're not concerned about k equals 5, an excluded value from this denominator that makes this denominator 0, because that appears in our answers here. In division problems, we need to look for excluded values in both the numerator and the denominator. Let's make a note of those and see if we've canceled any of them out. So here a k value of 2 would make this numerator 0. 2 minus 2 equals 0, so k cannot equal 2. In this denominator here, that would be negative 5. That's a new one. So k cannot equal negative 5. And we already had this one, k equals 2. Okay, looking at our answer, neither of these excluded values are apparent in our answer, either one of our answers. So let's make a note of that. So we have k plus 5 over negative k plus 5 for k not equal to 2 and k not equal to negative 5.